Welcome to our review on mains electricity in the home. First thing we need to understand then is what is actually inside a normal plug that we find in the UK. So the picture at the bottom there shows us what we find if we take that outer cover off. So what we've got is a fuse on the right hand side. We've got our cable grip and the outer insulation on the actual cable coming into it at the bottom. And then we've got 3 different wires that we need to know the names and the colours with their functions. So first of all, we've got our live wire, which is a brown colour, and this one is going to provide the energy to the device, and in the UK that would be 230 volts coming into it. In the middle we've got the yellow and green stripy wire, which is the earth wire, and the whole purpose behind our earth wire is that should a fault occur, the current will pass along it and make the device safe. And finally the neutral wire, which is the blue one on the left hand side, that one just completes the circuit and usually, if the appliance is working correctly, has no volts passing through it. Fuses then are important safety devices, and they actually protect our device from any surge of current. So what we find is our fuse is connected into the live wire as we saw in the diagram, and each fuse actually has a designated rating. So it will have 3 amps or 5 amps stamped onto it, and this tells us what current can flow through it without melting the internal wire. If the current passing through the fuse actually exceeds that value, then what happens is the thin bit of wire inside the fuse is going to heat up and melt. As soon as that fuse wire is melted, then the circuit is broken. So that means that no more current will flow through that appliance, and therefore it's protected from that surge. This is our second equation in P4, and again we'll find this printed on page 2 of the exam booklet. So power in watts is the current in amps times by the voltage measured in volts. And again, if you're doing the higher tier paper, you need to be able to rearrange this, so practice using those triangles. Put the actual values from the equation printed on page 2 into it, and then remember, if you are working out something different, you cover up the thing you want and it leaves you with the calculation you need to actually do. So to give you 2 examples down here, what we've got is calculate the power of a speaker which draws a current of 1.5 amps at 12 volts. So power is current times voltage, so our power is going to be 1.5 times by 12, which gives us our answer of 18 watts. And on the right hand side, a second example there, a TV has a power rating of 115 watts. Calculate the current when the TV is connected to the 230 volt mains. So if we cover up our current, then we need to do power divided by voltage, and that's going to be 115 divided by 230, so our current is 0.5 amps. One thing that they do ask you to do on the higher tier paper occasionally is to select an appropriate fuse for an appliance. So what you'd actually do is you'd calculate this current, okay, it normally follows on from the calculation of the current, and then the fuse would have to be just above that. So if we were looking at our TV, then we could have a 1 amp fuse, okay, because obviously the current flowing through it is going to be 0.5 amps, and we pick something just above that. Sometimes they'll give you some to select from in a list. If they do so, make sure you select from the one in the list. The earth wire then is a safety device. What we have is one end is connected to the metal case of the appliance, so that in the unlikely event that a live wire becomes loose and touches that metal case, what the earth does is it carries the current away. And as it does so, that causes a surge in current, which leads to the fuse melting, and as we've said, that breaks the circuit. If we didn't have an earth wire, what we would find is that us as users of these appliances would be at risk of shocks. But because obviously the earth wire carries away that current as soon as there's this fault inside and melts the fuse, it protects us from that risk of shocks. A second safety device that we could use is something called double insulated appliances. So a double insulated appliance actually has a plastic coating around the inside that's going to prevent the live wire touching any metal casing at all. So because it can't actually come into contact with the metal casing, then we don't need an earth wire because there's no chance of that casing becoming live. And the symbol we actually have for any double insulated appliance is shown at the bottom there with 2 squares, one inside the other.